we know that by definition this d, the exact solution of the difference equation, satisfies this equation like exactly, that is din plus 1 minus din over delta t is equals to alpha by delta x square di plus 1 minus 2 di plus di minus 1. So the right hand LHS and RHS will get cancelled and we are only left with error terms. So what does it look like? Epsilon n plus 1 I minus epsilon n I is equals to alpha delta t by delta x square epsilon n I plus 1 minus 2 epsilon n I plus epsilon n I minus 1. Now we are interested in, okay, since d is the exact solution of the difference equation, the d terms cancel out, okay, they match, they exactly satisfy this equation, that's why we end up with only the error terms. Now what we are interested in is, if this error, is this rounding off error increasing in time or not? That's the big question. So to do that, what I can do is, I can divide epsilon n plus 1 by epsilon n. So what do I get? Epsilon n plus 1 I over epsilon n I minus 1 is equal to, what do I get here? Alpha delta t by delta x square epsilon n I plus 1 by epsilon n I minus 2 plus epsilon n I minus 1 over epsilon n. Okay. Now this term epsilon n plus 1 I over epsilon n I, this ratio, the amplitude of this ratio is called as the modulus of this ratio is called as amplification factor. It is typically denoted by capital G. If this value is less than or equal to 1, we can say that our error is reducing in bounds. That is, if say we get an error of say 0.1 here, if the error is, say, let me denote it by, okay, error is say 10, at n time step, if the error is 10, the rounding of error, and if this epsilon n plus 1 is less than or equal to 10, what is going to happen? The error will be contained, the rounding of error will be the same. Say if it is 20, what is going to happen? The error will be twice as this, and at epsilon n plus 2, what is going to be? It's going to be twice of 2, that is 4, and after that twice of 4 will be 8. So what is going to happen? All your rounding of errors will be so large that your solution will no longer make sense. So to make sure, we have to say that this condition should be satisfied. Okay. Now we are going to make, we have to approximate this to a function. We'll say that epsilon is denoted by some kind of function, and then find out this ratio and see whether this explicit scheme is stable or not, and if it is stable, under which limits.